takes place in between primary refrigerant and secondary refrigerant. Later heat exchange takes place in between secondary refrigerant and air. Okay, this is what indirect refrigeration system is. So we'll discuss. So when we have a large applications, okay, when we have a large applications, in that applications we are going to use the indirect refrigeration system. Okay. Just allow me 1 minute. Okay, so now, so in the indirect refrigeration system we have AHU. In the indirect refrigeration system, first we are discussing all air system. In the all air system, what are the components present? In the all air system, what is the device we are using? We are going to use device which is AHU, right? We are using AHU. So AHU. So मुझे एक आंसर बोलो. Suppose if you are using a diesel generator for a small store like a medical store or internet shop, how much big it will be size, physical dimensions? How much big it will be?
One meter, sir, maximum.
Oh, so now Where will you place that normally?
Outside.
You place it outside, right? You place it outside. So as you place it outside, now sometimes you come to the application same diesel generator for a big shopping mall. Suppose if it is a big shopping mall, how much big it will be? It will be very big, right?
Yes, sir.
So as it is very big, where we place the diesel generator for that? As it is very big, where we place it?
We keep it in a separate shed outside
Separate,
itself.
like cellars, rooftop. Am I right?
Yes, sir.
सेल्लार पे होता है, नहीं तो रूफटॉप में होता है. So AHU is also as big as AHU is also as big as the diesel generator. So as it is as big as diesel generator, even AHUs we place on the cellars or in the rooftops. आजकल मार्केट पे क्या हो रहा है? What is happening in the market? आजकल मार्केट पे ये चीज हो रहा है, which we call as AHU rooms. AHU room separate place is providing to place to fix the AHUs. Okay. So these are the different types of applications, different types of different places where we place our air handling unit. Air handling unit is a cabinet which consists of filter, which consists of filter, cooling coil, and blower. Okay, we have filter, cooling coil, and we have blower. So this is the AHU. So suppose I have an application which requires application which requires 600 CFM of air, which requires 600 CFM of air. So as it requires 600 CFM of air, I need to cool, I need to take the air and I need to supply. Okay, I need to take the air, I need to supply from outside. Okay, as I need to supply from outside, so first we need to control the air. So we'll be having a VCD to to control the air from outside. We take 600 CFM of air. Now 600 of CFM of air we have taken. Is outside it is completely pure? Is outside it is completely pure?
No.
No. So first हमें क्या करना पड़ेगा, वो outside air को filter करना पड़ेगा, right? So
Yes, sir.
to filter the outside air, we are going to use
Sir, what is the CFM, sir?
who is asking that question?
Yes, sir.
कल का क्लास पे बोला था ना, CFM is the quantity of air, cubic feet per minute.
Cubic feet per minute. Okay.
That means you are not revising the classes, which is wrong. फर्स्ट क्लास में बोला था CFM क्या है, फर्स्ट क्लास में. I don't tolerate this again.
Sorry, sir.
You need to prepare and come, please. Why? Because these are the basic terms. Okay. Now, $600 CFM of air requires, वो एरिया को कूल करना है तो उतना क्वांटिटी ऑफ एयर जरूरी है. ठीक है. सो हमें बाहर से 600 CFM ऑफ एयर लेता है. ओके, 600 CFM ऑफ एयर लिया है, वो फिल्टर के पास आता है, फिल्टर होता है. Now when it comes to the cooling coil पे हमें क्या कर रहा है, हमें 5 डिग्री सेंटीग्रेड ऑफ चिल्ड वाटर सप्लाई कर रहा है. We are supplying 5 डिग्री सेंटीग्रेड ऑफ चिल्ड वाटर. सो ये एयर 40 डिग्री सेंटीग्रेड का गर्म एयर है. ये एयर इधर आता है, एक कूलिंग कॉइल के पास आके वो कूलिंग कॉइल पे क्या हो रहा है, इन द कूलिंग कॉइल इट्स गेट्स कूलिंग डाउन. एज इट इज गेटिंग कूलिंग डाउन, एक और प्रोसेस भी हो रहा है, दैट प्रोसेस इज कॉल्ड एज अ डीह्यूमिडिफिकेशन. क्योंकि अभी 5 डिग्री सेंटीग्रेड को हमें ड्यू पॉइंट टेम्परेचर बोल सकता है. 5 डिग्री सेंटीग्रेड इज अ ड्यू पॉइंट टेम्परेचर. वो कितना होना है वो हमें कैलकुलेट करता है बेसिकली. So now we have taken 5 degrees centigrade for cooling and dehumidification. So cool और dehumidification होने के बाद वो comfort air हो जाएगा. It becomes the comfort air. Now as it is the comfort air, this air needs to reach from here to the room. So as it needs to reach from here to the room, हमको क्या जरूरी है, हमको एक pressure जरूरी है. So that pressure was provided by the blower. Blower can pressurize the air to reach its destination. Got it? Clear? Now, as the air needs to reach from here to here, so we'll be having a duct. So which is called a supply air duct. So we'll go with supply air duct. Now as we go with supply air duct, so we are taking the air from outside, we are filtering. After filtering, we are using, just allow me 1 minute. Okay, so we are filtering. After filtering, what we are doing, we are cooling. After cooling, we are throwing the air from here to here by using the duct. So basically, how duct is made, how ducts are made, anyone have idea?
Document aluminum sheet या flexible duct to use.
It may be with aluminum sheet or GI sheet, right?
GI, yes sir, GIC.
Yeah. So those are good conductors of heat. Suppose if I am throwing the air, if I am throwing this air, okay. If I am throwing this air, now ये मैं 24, 23 or 22 डिग्री सेंटीग्रेड का एयर थ्रो कर रहा हूँ, सोचो, ठीक है. एज आई एम थ्रोइंग 22 डिग्री सेंटीग्रेड ऑफ एयर, ये रूफ टॉप में है, फिर ये 40 डिग्रीज को एक्सपोज हो रहा है, तब इसका टेम्परेचर बढ़ने का चांसेस है ना? चांस है नहीं है?
Yes.
तब इतना करने का फायदा क्या है? कुछ नहीं ना. इसीलिए हमें क्या करना है, हमें इंसुलेशन प्रोवाइड करना है. क्या करना है? वी नीड टू प्रोवाइड द इंसुलेशन. Okay, so what are the best insulating materials? Can anyone have idea?
Nitrile rubber.
Very good. Nitrile rubber.
Rock wool.
Rock wool. Fiberglass.
అల్యూమినియం క్లాడింగ్ కూడా ఇన్సులేషన్ కింద వస్తుంది సార్.
Aluminum cladding is a protector.
ప్రొటెక్టర్. ఓకే.
Okay, so we have a insulation. Now as we have a insulation, we have throwing this air from here to here and it is coming to the room. Will this air makes you comfort? Will this air makes you comfort?
Yes sir.
Comfort. Yes. Okay. So this air will not make you comfort. Why? Because this air may come and may go like this only. इतना एरिया ही कंफर्ट करेगा वो. ओके, सो इसलिए हमें क्या करना है, वो एयर को हमें डिस्ट्रीब्यूट करना पड़ेगा. ओके, टू डिस्ट्रीब्यूट दैट एयर we use the yesterday क्या बोला है मैं we use the terminals. Terminals are like air showers. Okay, it throws the air in different directions. Like this air different directions में air को throw करता. Okay, now
सर सर इंसुलेशन थिकनेस का कुछ होगा ना कि कितना mm का इंसुलेशन थिकनेस होना चाहिए?
मैं आता हूं सर, मैं कल ही बोला था at the end I'll take for questions at that time पूछो. Okay, if I won't define that वो टाइम पे पूछो, मैं बताता हूं. I'll come to that point. Okay, so as per calculations, as what they are telling, 600 cubic feet per minute, right? 600 cubic feet per minute. मैं फर्स्ट मिनट में 600 क्यूबिक CFM में सप्लाई किया. सेकंड मिनट में फिर 600, टोटल 1200 CFM हो जाएगा. थर्ड मिनट में फिर 600, ये हो जाएगा 1800. 10 मिनट्स हो गया, ये हो गया 6000 CFM. 60 मिनट्स हो गया, ये हो गया 36,000 CFM. नाउ 1 आवर पे इधर 36,000 CFM है. विल इट मेक कंफर्ट?
No, sir. No, sir. No.
Make comfort here. Hello. Will it make comfort here?
No, sir.
No. Why? क्या होता है कंफर्ट नहीं? वो लोग बोल रहे हैं 600 क्यूबिक फीट पर मिनट चाहिए, हमें 600 क्यूबिक फीट पर मिनट नहीं मेंटेन ही कर रहा है, फिर क्यों कंफर्ट क्यों नहीं होता है? कंफर्ट क्यों नहीं होता है?
Because there may be a rise in temperature of the air which we provided before.
क्या होता है राइज इन टेम्परेचर? क्यों टेम्परेचर का राइज हो रहा है?
सर रिटर्न नहीं है उधर सर.
वही है सर, रिटर्न नहीं दिया तो क्या होगा उधर? फर्स्ट पॉइंट वही है.
Sir, pressure
सर
increase होएगा.
एक बार रूम फुल प्रेशराइज हो जाएगा, उसके बाद से उधर एयर आना बंद हो जाएगा सर.
वेरी गुड, राइट पॉइंट. मेरा पूरा 10 साल टीचिंग एक्सपीरियंस में पहली बार राइट आंसर मिला है मुझे, क्योंकि रूम प्रेशराइज हो जाएगा, रूम प्रेशराइज होने से फ्रेश एयर आना बंद हो जाएगा. राइट, ओके, फ्रेश एयर आना बंद हो जाएगा. इज दिस रिकमेंडेड कंडीशन? नो. ये क्या बोल रहा है? व्हाट दे आर टेलिंग, एज पर द टर्म्स 600 CFM मैं सप्लाई किया तो इफ आई सप्लाई 600 CFM रिटर्न भी करना पड़ेगा. व्हेन आई सप्लाई 600 CFM रिटर्न भी करना पड़ेगा. सो वी नीड टू हैव अ रिटर्न टर्मिनल. इधर 600 CFM मेंटेन करना है, दैट्स इट. हमें क्या करना है? 600 CFM मेंटेन करना है. Now, my question is, what is the basic principle of a design engineer? Design engineer का basic principle क्या है?
सर डिजाइन इंजीनियर का बेसिक प्रिंसिपल है कि कंफर्ट जोन प्रोवाइड करना
ठीक है.
ईच वन एरिया में.
ओके, वेरी गुड. स्टिल मैं सिर्फ HVAC का नहीं पूछ रहा हूं. दुनिया में कुछ भी डिजाइन इंजीनियर एक डिजाइन के ऊपर काम कर रहे तो उनका दिमाग में फर्स्ट प्रिंसिपल क्या होना है?
सेफ्टी आल्सो.
सेफ्टी. ओके.
Cost control.
Cost also.
हाँ, क्या होना है?
Cost control.
कॉस्ट कंट्रोल.
Cost control होना है. ठीक है. So in this project, how will you
Investment.
control the cost?
Sir, some area need for the 400 CFM. We are the design 800 CFM. 400 is lost now. That's why
इसलिए
we
तो
are the
डिजाइन कर
proper.
रहे हैं ना हमें.
हाँ.
The design is that for that only, right?
So this is the control. For example, we need 5 TR chillers. We put 10 TR. Na? This is the energy loss. Na? Cost is high. Na?
That is why we are doing designing, right? वो कैलकुलेशन इसलिए करता है ना, वो exactly कितना चाहिए उतना लेने के लिए. Basically losses कैसा होता है? Losses, how we define losses in two types. One is one time loss and second one is lifetime loss. One time loss है और lifetime loss है. ये one time loss means the basic initial investment of the project. प्रोजेक्ट के ऊपर आप कितना इन्वेस्ट कर रहे हैं उसको बोलता है मैं वन टाइम लॉस. नेक्स्ट, lifetime loss. Lifetime loss means whatever the project you are running, the running cost of the project. Okay, the running cost of the project is taken as lifetime loss. So if you take any project, which will be the maximum running cost or one time cost or running cost?
Running cost, sir.
Running cost, right? Running cost will be more. Okay. So here, being a design engineer, you need to minimize the running cost of the project. Okay, you need to minimize the running cost of the project. So in this project, how can you minimize the running cost here? How can you minimize the running cost?
We can again supply the same air which we are taking out from the area.
Repeat.
We can again supply that same air which we are taking out from that area.
Why? If I take that air, what happens?
It may take some less.
Sir, air will recycle and heat loss will be lesser, sir. By using this technology, we can save power consumption, sir.
Correct.
Can you come once again?
Sir, if we are taking continuously fresh air and giving out whatever excess air quantity out, Okay, instead of that, if we are using return air duct till AHU filter, we can save power supply, sir, and heat loss will be lesser, sir.
Yes, right. Yes, Santosh, you have some doubt. Tell me. Santosh, you there? So by reusing this air, okay, by reusing this air, we can save the power.
But sir, some area we are not using the return now. FHU use the.
Yes.
So
that I'll come to that point. We'll discuss that point. Okay. So either make note that point, will come to there. उधर भी हमें कैसा सेव कर सकते हैं मैं बताता हूं आपको.
okay.
इधर मैं रिटर्न एयर का सप्लाई टेम्परेचर इज 22 डिग्रीज. रूम पे कितना मेंटेन कर रहा है? 24 मेंटेन कर रहा है. रूम पे यू आर मेंटेनिंग 24.
Okay, sir.
In the room you are maintaining 24, right?
Yes.
Now 1 minute होता है. 1 minute के बाद this air will go from room to outside, right? So it may be around 30 degrees centigrade max to max. 5 degrees का फर्क हो सकता है 1 मिनट पे. Okay.
Yes.
Now as it is 5 degrees and 30 degrees centigrade, cooling 40 degrees centigrade to 22 degrees centigrade is easy, or 30 to 22 is easy.
Sir, delta T 6 degree.
40 को 22 लेके आने के लिए ज्यादा खर्चा होगा, नहीं तो 30 को 22 लेने के आने के लिए ज्यादा खर्चा होगा.
40 डिग्री को 22 लाने में ज्यादा खर्चा होगा सर.
42 को 20 लेके आने के लिए ज्यादा खर्चा होगा. सो हमें ये 30 को यूज किया तो तब इधर ये 5 डिग्रीज को चेंज कर सकते ना, मैं 10 तक लेके जा सकता हूँ ना.
Yes.
When the delta T is changed from between these two, chilled water supply and chilled water return, you need to remember, suppose इधर ये 15 डिग्री सेंटीग्रेड आ रहा है return temperature, when I use 40 to 22, मैं ये 30 को यूज कर रहे थे, इसको मैं 10 का देने को जरूरत नहीं, इसको 5 देने को जरूरत नहीं. 10 भी दिया तो वो कूल हो जाएगा, क्योंकि the difference is 30 minus 22, 8 degrees centigrade itself.
Yes.
8 degrees centigrade. Now तब डेल्टा टी इधर कितना डेल्टा टी कम होगा इन दोनों का बीच में, सप्लाई और रिटर्न का. सप्लाई इधर ये पॉइंट सुनना, सप्लाई वाटर चिल्ड वाटर सप्लाई चिल्ड वाटर रिटर्न के बीच में डेल्टा टी कितना कम होगा उतना पावर कंजम्पशन कम हो जाएगा.
Yes.
Just be on hold. Okay, now so I am reusing this here again. So इसको भी हमें इंसुलेशन करना पड़ेगा. इसको बहुत इंपॉर्टेंट है सर इंसुलेशन करना, क्योंकि इफ 30 को 1 डिग्री भी चेंज हो गया, दैट मीन्स इट इज गोइंग टू इंक्रीज द कॉस्ट ऑफ योर प्रोजेक्ट. इधर 30 का प्लेस में 32 हो गया, वो विल दैट इंक्रीज द कॉस्ट ऑफ द प्रोजेक्ट, रनिंग कॉस्ट।
Yes, running cost.
सो इसलिए इसको ज्यादा प्रोटेक्ट करना पड़ेगा सो दैट यू कैन मिनिमाइज द कॉस्ट्स। इसमें एक बहुत मेजर प्रॉब्लम एक है, क्या है वो? इसमें एक मेजर प्रॉब्लम एक है, बताओ ना। इसमें एक प्रॉब्लम है, इफ आई रीयूज दिस एयर तब क्या होगा?
स्मेल
फ्रेश एयर कम रहेगा.
फ्रेश एयर का कम नहीं, फ्रेश एयर का कॉन्सेप्ट ही नहीं। इफ सेम एयर, इफ आई एम रीयूजिंग द सेम एयर तब क्या होता है, कुछ देर के बाद इधर ऑक्सीजन जीरो हो जाएगा ना। Is it recommended again?
No, sir. We need to add some fresh air also, and we need to add in coil side. We need to add thermostat with actuator, sir. Or if electronic extension wall, then we need to add thermostat also, sir.
Okay. So हमें क्या करना पड़ेगा? हमें कुछ फ्रेश एयर को भी ऐड करना पड़ेगा। So what I am doing, I am exhausting 10 CFM here. 10 CFM को exhaust कर रहा हूं। And I am taking 590 CFM from here. I am adding 10 CFM of fresh air from here. Right? Every cycle I am doing this. Okay, in every cycle if I am doing this, will it balance my fresh air oxygen level? So it is going to balance the oxygen level. So here, how the 10 CFM is defined, we'll see here. First minute में एक साइकिल हुआ है, कितना फ्रेश एयर ऐड किया? 10 CFM ऐड किया। सेकेंड मिनट में फिर 10 CFM, टोटल फ्रेश एयर 20 CFM नाउ। थर्ड मिनट में फिर 10 CFM, टोटल 30 CFM। ऐसा 10 मिनट्स में कितना हो गया? 100 CFM हो गया। 60 मिनट्स में 600 CFM हो गया।
600 हो गया। So
अभी 60 मिनट्स में
So we are use exhaust fan also, sir, same place.
Where you are talking? Okay, it is 600 CFM. Now in 600 CFM, in 60 minutes, this 600 CFM is replaced with 600 CFM, right? पहले कितना CFM था? इधर 600 CFM था। मैं एक एक मिनट में 10-10 CFM ऐड करते से 600 CFM से रिप्लेस हुआ नहीं हुआ? $600 CFM से इधर रिप्लेस हुआ है। कितना बार हुआ है? 600 CFM is replaced with 600 CFM one time ही 600 CFM से रिप्लेस हुआ, which is 1/8 change। कितना टाइम लिया है? 60 मिनट्स लिया। 1/8 change per hour। Got it?
Yes.
So residential applications, requires one air change per hour. Commercials like bars, we come with malls, airports, which requires with 2 air changes per hour. Suppose if I need to achieve 2 air changes per hour, कितना CFM exhaust करना है मैं?
20.
We need to achieve 20. We need to go with 20 CFM, right? Next, bars, pubs, restaurants. It requires with 3 air changes per hour. And industries, it requires with 6 to 10 air changes per hour. Clean rooms, it requires with 20 to 240 air changes. Air changes per hour. These are the Astra recommended. Okay. According to this, suppose if my project is airport, what we'll do? We'll exhaust 20 CFM every minute, and we'll take 20 CFM of fresh air every minute.
Okay, sir. Negative pressure room and positive.
Where?
Isolation room we are using in hospital.
I'm not getting your question.
Isolation room for corona patient is like design air exchange
Yes.
per hour.
Yes.
HVAC system design.
Yes. There you need to maintain negative pressure.
Yes.
So how to achieve negative pressure will come there. When we're discussing the ventilation concept.
Air exchange per hour.
Already my diya na idhar. Clean room. If it comes under clean rooms, 20 to 240. Again, there will be their own specifications. You need to refer National Hospitality Standards again.
Clean room. Okay, sir. Sir, we have one doubt.
Yes.
This room 600 CFM. Okay, but we are install exhaust fan also, na sir, this same room.
Exhaust?
Exhaust fan.
What is the use of exhaust fan in air conditioning room?
Each one I have 6 HU same, but with connect exhaust fan also, sir.
Where? To the AHUs or in the room?
In room. Each room.
In the room you have exhaust fans for air conditioning room.
Yes.
I don't know, sir. We need to check the KPIs, key point indicators of that project.
Okay.
It can't have. मैं कभी भी ऐसा डिजाइन नहीं देखा अभी तक. Okay.
Vinod sir, this
Yes.
who will decide that this room required 600 CFM?
You decide. You will decide.
Is there any specific formula for this, sir?
There is a big calculation. That calculation part goes 3 days.
Okay.
Okay, so if somebody asks me to develop a design for the room, then
Yes.
how will I come this to this number of CFM?
That is why I am here, sir, to teach you all those things, right?
Okay.
I am telling how the system works now.
It will come under heat load calculation. So you will let you know later.
Yes. I'll tell you how to calculate that. Okay.
Okay.
So now where we are. Okay, till this concept it is clear, right? Everyone, any
Yes.
doubts in this now? It's not
Vinod sir,
ISO standard, it's a standard from ASHRAE.
Vinod
These
sir,
are ASHRAE standards. Yes.
సార్ ఇప్పుడు ఏహెచ్ రూమ్ అనేది క్లోజ్డ్ ఏరియాలో కూడా ఉండొచ్చా?
Anywhere it can be. If it
ఓకే
is in a closed room, then again we'll run a duct for fresh air from outside.
ఓకే. ఇన్ కేస్ మనము ఆ విండో ఓపెన్ చేసి ఓన్లీ నార్మల్ వెంటిలేషన్ టైప్స్ ఉంటాయి కదా సార్, గ్లాస్ టైప్ స్లైడింగ్ గ్లాసెస్ అవి కూడా పెట్టుకోవచ్చు కదా సార్, ప్రాబ్లం ఉండదు కదా?
పెట్టుకోవచ్చు, ప్రాబ్లం ఉండదు.
ఓకే సార్.
Sir, does the weather conditions may differ with the operations? If there is a cold air outside, we are taking as a fresh air. Will it make any difference in the operations?
I'm not getting your question exactly.
If it's a winter season, we are taking fresh air from outside, which already has some less temperature, no? So,
Yes.
will it make any difference in the operation, like difference?
Yeah, I'll come to that point.
Okay.
Till here it is clear, right?
Yes, sir. This is clear. But sir, FAHU you are explaining now. Then.
Yeah. So
Okay.
FAHU means, suppose here, see, in the clean rooms where we are not supposed to take the fresh air, so the exhaust air. Okay, when I come to the explaining of this AHU, types of AHU, I'll come to that point.
Okay.
Okay, clear? Either तक clear है ना?
Yes, sir.
Okay. So ओके कंप्रेसर में क्या होता है पहले इन द कंप्रेसर व्हाट हैपेंस
suck the refrigerant from the return line and discharge the refrigerant to condenser.
कंप्रेसर का काम क्या है
Compress the refrigerant, then high pressure and high temperature.
कंप्रेसर का काम कंप्रेस द रेफ्रिजरेंट फ्रॉम low pressure to high pressure. That means high volume to low volume, right?
Yes.
Now, compressor compresses the refrigerant from high volume to low pressure to high pressure. So high temperature will be there. High temperature refrigerant.
Yes.
Now from here I am supplying cold water. What we are supplying? Cold water by using a pump. This is condenser pump. Both are condenser pumps. So I am supplying cold water. Either heat exchange होता है, hot refrigerant होगा, cold refrigerant.
Yes.
Cold refrigerant होगा, cold water होगा, hot water, right? Hot water again pumped back. Okay, and we throw this water in the form of tiny water droplets.
It's like spray, na?
Spray. So we'll be having an axial fan here. This fan removes the heat from here. So this setup is called cooling tower. What it is?
Cooling tower.
Cooling tower. Now when the heat extraction is happening, when there is a heat extraction happening, तब कुछ वाटर भी evaporate होने का chances है, right? There is a chance that some water also may get evaporated. So to balance that water, okay, to balance that water, what we are doing is
balancing tank.
We are using a
Makeup water tank.
Makeup water tank to balance this water. And this piping is called as condenser piping. Condenser piping. Now, coming to the condenser piping के बाद cold refrigerant will enter into the expansion valve and will become chilled refrigerant. What happened? It becomes a chilled refrigerant. Now, as it is chilled refrigerant, now in this piping already water is charged. We have charged the water. So as to the chilled refrigerant, allow me 1 minute. Okay, as it is chilled refrigerant compared to chilled water written 15 or 20 degrees centigrade, you socho. Oh, hot water here compared to the refrigerant temperature. So we'll supply hot water. Now here heat exchange hoga, chilled refrigerant will become hot refrigerant and hot water will become chilled water. This chilled water is supplied to the AHU to make the cooling. Okay, in the cooling coil. Now these pumps are called as chilled water pumps. And this piping is called as chilled water piping. Now, and this setup is called as chiller. Now, as these two temperatures are very less than the ambient temperatures, right? Ambient temperature कितना है 40 degrees centigrade है. As both are very less to the ambient temperatures, so we need to provide insulation right here. हमें इधर भी insulation provide करना है ना?
Yes, sir. Yes, sir.
This insulation is puff insulation. Puff insulation. So do we need any insulation here?
No, sir. Insulation not required for that area, sir.
Yes, why?
Because it's nearly to ambient temperature, sir.
Those are dealing with ambient temperatures. Okay, very good. Those are dealing with ambient temperatures. Okay. So this is chiller, this is cooling tower, this is makeup water tank, this is chilled water piping, chilled water pumps. Puff. Puff means polyurethane foam. Puff means polyurethane foam. So any doubts still here?
Sir, instead of puff insulation, we can choose nitrile rubber and thermocol section also, no, sir?
See, here choosing of insulation is completely depends on, okay, choosing of insulation is completely depends on the local availability.
Okay, sir. Okay, sir.
विनोद सर,
Yes.
यहाँ पर जो ये हॉट वाटर आ रहा है ऊपर से, ये हमें हॉट वाटर इंसुलेशन पफ इंसुलेशन देके हॉट वाटर ही डालने की क्या जरूरत है? हमें तो चिल्ड वाटर चाहिए ना उधर.
कहाँ?
In this,
Yeah.
yeah, right, sir.
Hot water means ये रेफ्रिजरेंट के हिसाब से ये हॉट वाटर है. मैं 5 डिग्रीज का सप्लाई कर रहा हूँ. रिटर्न में भी 15, राइट?
Right.
15 इज नॉट हॉट वाटर फॉर एम्बियंट. एम्बियंट के हिसाब से एम्बियंट 40 है.
Okay, right.
सो ये कितना इंक्रीज होगा उतना पावर कंजम्पशन बढ़ेगा इधर.
Okay, right. So this is not the hot water. This is the.
विथ रेस्पेक्ट, इसलिए मैं 2 बार बोल चुका इधर. With respect to the chilled refrigerant temperature.
Right.
So here, water itself is a refrigerant, no?
Yeah.
Sir, please zoom out, sir, for whole diagram, sir. In one
Yeah, I'll
single page.
give them. Just allow me 1 minute. I'm searching for one image. Just watch this video so that you can understand very clearly.
Chiller system. Centralized air conditioning system used for large cooling capacity, usually for commercial purposes. Chiller system consists of three main cycles, which are refrigerant cycle, chilled water cycle, and condenser water cycle. The components that are involved in refrigerant cycle are compressor, condenser, filter dryer, expansion valve and evaporator. For chilled water cycle, the component which involved are air handling unit and water pump. In condenser water cycle, the component that are needed for the process are cooling tower and water pump. Refrigerant cycle. Refrigerant cycle consists of four basic components, which are compressor, condenser, expansion device and evaporator. An additional component called filter dryer also included in the system. Compressor. Compressor works to increase the pressure of the refrigerant. In addition, it also serves to increase the temperature of the refrigerant higher than the temperature of condenser water so that the heat transfer can occur in the condenser. The refrigerant enters the compressor with low pressure gas and out with a high pressure gas condition. Type of compressor used was scroll hermetic type. Scroll compressor works based on gas at low pressure and temperature enter the suction line and go into the compressor. The low pressure and temperature gas is pressurized by the scroll compressor to high pressure and temperature gas. The high pressure and temperature gas is then passed through the discharge line and then go into the condenser. Condenser. The refrigerant in high pressure gas will be enter the condenser at a temperature higher than the temperature of condenser water. In condenser, the heat will be eliminated to the condenser water from the cooling tower through the process of convection and conduction. After the heat is removed, the refrigerant in high pressure gas is condensed into a high pressure liquid when out of the condenser. Condenser most commonly used is shell and tube type. Water is flowing through the tube while refrigerant liquid flooded in the shell. Filter dryer. Before the refrigerant flow to the next main component, it will be passes through an additional component called dryer. Dryer acts as a dirt filter and absorb if there is moisture in the refrigerant. This ensures that refrigerant is clean and dry before entering the expansion valve. Expansion valve. Expansion valve serves to reduce the pressure and control the flow of refrigerant going into the evaporator. When the pressure of refrigerant has declined drastically, the temperature will drop dramatically, which is lower than chilled water temperature. In a centralized system, expansion device DXV thermal expansion valve type is used. It works according to the temperature of the refrigerant which comes out from the evaporator. Sensing bulb placed on outflow of the evaporator works to detect temperature of the refrigerant and sends a signal to TXV. Needle valve in the TXV will control the flow of refrigerant based on the transmitted signal. Evaporator. The refrigerant in low-pressure liquid form coming out from the expansion valve will flow into the evaporator at low temperature. In evaporator, the heat from the chilled water which comes out from the air handling unit will be absorbed by the refrigerant due to the temperature difference produced. When the liquid refrigerant with low temperature and pressure absorb heat from the chilled water, the refrigerant will evaporate to low-pressure gas. The evaporator most commonly is used shell and tube type. where the refrigerant flow in the tube and the water flooded the shell. The evaporator is insulated with an insulation to reduce heat transfer. The refrigerant in low pressure gas will return to the compressor and continue to the next cycle. Chilled water cycle. Chilled water cycle consists of two basic components, which are air handling unit and water pump. Air handling unit. Air handling unit is a place where cold air is produced before it can be distributed. It consists of several key components such as cooling coil, fan motor, belting, filters and the casing. Chilled water produced in the evaporator will be flow into the air handling unit through a pipeline which is marked with dark blue color. This chilled water is known as chilled water supply. In air handling units, chilled water will then pass through the cooling coil. In the cooling coil, the hot air will go through the cooling coil and switch to cold air due to the heat transferred to chilled water. Cooling coil are commonly used in this system are tube and fin. After absorbing heat from the hot air, the chilled water will be known as chilled water return. Normally chilled water return will be colored with light blue. Chilled water return will return back to the chiller to transfer the heat absorbed to the refrigerant in the evaporator. Water pump. This cycle will continue as long as the pump is functioning well. The pump used in the system is centrifugal type. The centrifugal pump works based on centrifugal force produced by the rotating impeller in the pump casing. For airflow system, it is operated using an auxiliary fan which to create the air cycle from the room and mix it with fresh air from the outside to the air handling unit and return back to the room. Type of fan used was centrifugal fan and powered by a motor and connected through a belting. The air flowing through a channel is called ducting. There are two types of air duct which are supply air duct and return air duct. These air ducts are coated with insulating material consisting of fiberglass wrapping with aluminium foil. It reduces heat transfer from the environment to the air duct. Air return to the air handling unit will pass through the filter before passing through a cooling coil and return back to the room. This to ensure that the air return into the room in a clean condition. Condenser water cycle. Condenser water cycle consists of two basic components which are cooling tower and water pump. Cooling tower. Cooling tower serves to cool down the temperature of condenser water that will be used to absorb heat in the refrigerant at the condenser. It consists of several components which are motor, sprinkler blade, water fin, water reservoir, buoys, and make-up water tank. From the condenser in chiller, condenser water flow to the cooling tower with the help of a centrifugal pumps. This chilled water is called condenser water return. This condenser water will pass through the rotating sprinkler blades on cooling towers. This rotating rotor blades using pressure generated by the condenser water itself. Water will gush down through the fins to reduce the speed of water going down. This can delay the time and the heat can be absorbed more effectively by the surrounding air that passing through the fins. Air through the fins is forced by a rotating fan on the sprinkler blade rotated by the motor. This fan rotates with its gusts upward. This will cause the air to move from the bottom to the top of the cooling tower where it is opposite to the flow of the condenser water. Condenser water which have eliminated their heat by the surrounding air will accumulate in the basin under the cooling tower. Condenser water that flowing out from cooling tower to the chiller is called condenser water supply. This condenser water will flow back to the chiller to continue heat absorbing work from the refrigerant. The buoy system at the water basin is connected to the make-up water tank. It works for adding water when the water level in the basin decreases at certain level due to evaporation. This condenser water cycle will continuously flow as long as the centrifugal pump is in good working condition. This explanation hopefully will enhance the student comprehension regarding the system. The centralized air conditioning is the commonly used system, and it's very important to the student to well know the system.
Hope you got some clarity, right?
Right.
Yeah. So now note down this drawing. So this is one of the most important question in the point of interviews. When you give interviews for bigger companies like Shapurji, Polanji, or you go for L&T, so they only ask you to explain how all air system works. Why? Because this is a complete air conditioning cycle in the industry oriented. Okay, please make a note of this.
Sir, zoom out some more, sir.
Some more zoom out or zoom in? Zoom.
Zoom out.
Like this?
No, sir. Opposite. The right side part is missing somewhat.
Make it fast.
Done, sir.
Done, sir.
Yeah. Everyone done?
Yes, sir.
Okay. So your assignment is write a simple description how all air system works. Write a simple description how all air system works. So by when I can get this? By when I can expect this?
Sir, please repeat question, sir.
Write a description how all air system works. So can I get by tomorrow evening?
Okay, sir.
Okay. So any questions for the day? Any questions you have?
नो सर, बट सर इसमें सर जहाँ पे भी HU इधर हॉस्पिटल में इंस्टॉल किया है ना सर, वहाँ एग्जॉस्ट फैन लगाया आएगा, वो क्यों लगाया है उसका भी CFM पे बहुत फर्क पड़ेगा ना, वो बाद में आएगा क्या H1 रूम में?
मुझे तो मैं वही बोल रहा हूँ ना, I am first time I am listening there is exhaust fan in the air conditioning places. I'll check it.
Okay sir.
I'll check it. Okay.
Okay.
Okay. Any doubts till here? Okay.
No,
so
sir.
we'll take break for the day. So from Monday, so we'll start on all water system and duct designing. Both concepts will start. Duct, all water system will take 1 hour, and duct designing will take next. From there we'll start. Okay. Hope you
Okay,
are
sir.
clear with the AHU. AHU part is most important. The next day